So I am Stephen Wylie, and I'm from Dallas. I'm a Google developer expert out there, and I'm going to be presenting on fusing artificial intelligence with augmented reality on Android. So let's click through all this stuff. So yes, fusing AI with AR. So I'm going to talk about how we go about doing this and show you some really interesting examples of how to make it work with TensorFlow Lite and all the goodness that goes on involved with that. So a little bit about me. As I kind of explained GDE and machine learning, as you can see on the slide, there's a lot of things I do, too many things, and some of them are going to go away after I have my baby in December, my first kid. So this is cool. But yeah, that's pretty much where I'm coming from at this point. One thing I want to emphasize is that I do have quite a few patents in this area. I've acquired about 22 or 23, I think, so it's up there for sure. So does anybody do this themselves? Like, who's actually out there building some AI plus AR examples? And let me show you that, yes, in fact, of course there's a ton of people that are doing this, but they're probably all using help. They're probably not all doing this themselves. One interesting example on the left is Capital One, because I worked on that one back in 2017. So basically, if you imagine downloading the Capital One Auto Finance app, pointing your phone at a given car in a dealership lot, the artificial intelligence will recognize what the make, model, year, and trim of the car is, and then our augmented reality piece of it will actually convey to you your rate, monthly payment, what the vehicle is, and then you can keep doing this for multiple cars and then stand back and see basically the whole spectrum of all the cars that you have asked for. And so it's a good way to do comparison shopping right on a dealer lot. Then, of course, we've got Wayfair that has some really cool augmented reality tools for looking at how your new furniture that you want to buy is going to fit into your house. Will it fit? Will it not fit? Is the color going to be right? Etc. And Wayfair can help you solve this. Now, I think the overall coolest one in my book is Home Court. This is a sports coaching application where if you play basketball, it will actually analyze where on the court you're standing. It will draw a dot where you took your shot from. It tallies up your score on the backboard, and then depending on whether you made or missed the shot, it actually will draw different colored dots so that you can see where on the basketball court you're actually doing the best and where you could use some improvement in your game. So any of you basketball players out there should definitely try this, I think. Super cool. So key terms to get to know for doing the augmented reality and artificial intelligence parts. So y'all are already machine learning people, I'm sure. So all these are pretty common to y'all. MobileNet, Squeeze, and Inception Resident, of course, being the models we use to do object detection, basically finding the bounding box around some object of interest. And then we will learn those coordinates, and those coordinates become useful for us later on in the concept of where we're going to draw stuff. Now, TensorFlow Lite is interesting. So this is a really crucial technology to getting this to work. Now, of course, regular TensorFlow for various types of devices, but TensorFlow Lite is really optimized for your mobile phone because it's written in such a way where they really have paired up and gotten high collaboration with the GPU manufacturers for your mobile phones. And so it knows all the specific instructions and specific like ASIC submodules and things involved with making certain operations happen. And so there's probably hundreds of custom mathematical operations that have been implemented in TensorFlow Lite to go along with the optimal route to make your phone perform fastest and quickest on doing machine learning. Then, of course, ML Kit, and this is cool. So these are APIs that enable specific machine learning use cases on devices or cloud. Nowadays, this comes through Firebase, and you can download things for Cloud Vision, Cloud NLP, a lot of different kind of stuff, barcode scanning, etc. And thing is, though, ML Kit's usually not something you train. This is something that just kind of comes as a package for you. But it's still interesting to point out that it's there anyway. Then we'll talk about the augmented reality side of it just a bit. So a key component that makes this all work from actually rendering stuff on screen is AR Core. Now, this is really basically a thin wrapper around OpenGL for any of you that have ever done 3D graphics programming. So when I was first looking at this thing and I wanted to draw one of those speech bubbles above the car for Capital One, I was looking at about 300 lines of boilerplate code to implement just to draw a little text box on the screen to tell me what the price was. Well, luckily we've gotten better these days, and now there's scene form. So SceneForm is a Google technology that you can use for Android that abstracts away a lot of this OpenGL madness and allows you to directly interact with objects on screen in the form of some kind of like OBJ file that you might recognize from like 3D Studio Max or something if y'all do 3D rendering. And utilizing SceneForm will be the quickest way to actually get this thing to work. So, in the process of getting this thing to work, let's talk about establishing your Android app. Several steps involved with establishing your Android app, and the first ones we're going to talk about is getting your prerequisites and cloning the repository. This is kind of an interesting process. It takes a lot of trial and error to get this all to work. So first things first, you want basically the latest version of these 5 components. Android Studio, get the latest Android API, which actually now is the Q preview, I think, but you can go along with the latest version of Android Pie, which I believe is 28. You need the Android NDK, which is your C++ build tools for Android, very important. And then, of course, you want the Gradle plugin to facilitate your builds. And finally, Bazel. How many of y'all here use Bazel? I see like a couple of hands, I think. So yeah, there's some more back there too. So about 5 people maybe have admitted to using Bazel. Well, this is going to be, for those of you that may be intimidated by it, yes, it can be intimidating, but it's definitely worth learning for this process. Now, the next thing is, again, through trial and experimentation, use Java JDK 10. Not 11, you get a certain set of errors. Not 8, you get a certain other set of errors. So this works best with 10. Then if you're building in Windows, you're going to need a whole bunch of stuff like this, the Visual C++ build tools that you download from a specific file. Now this was specific to my laptop where I already had some version of it installed. It complained that I was reinstalling the same thing and yet was still telling me about missing dependencies. That wasn't good. So I figured out this is what you got to do. And then you got to move around some of these build tools from various folders into the 10.2.40 directory for it to work. Otherwise, it's going to complain about missing libraries. And the .NET Framework SDK is important. And then get a real shell like MSys2, not using PowerShell, not using the CMD that comes from Windows. Now, incidentally, when you download Git Bash and install Bash from Git, then this actually gives you the MSys2 shell, which acts a lot like the Linux shell inside of Windows, which is super cool. Now, there's a shortcut to all of this stuff. Microsoft, in their graciousness, has actually facilitated the use of VMs that you can use if you wish to download this in an environment from scratch directly on Windows. Now, of course, if you're using Mac or Linux, you don't really have to worry about all this stuff. You could even put all this stuff inside of a Docker container in Linux if you wanted to. Speaking of which, it's time to pick your poison now. You're going to download TensorFlow source from GitHub or from Docker. Now, in my case, I used GitHub just because I was building directly on the computer itself, not through a Docker container. So let's talk about that part now. We're going to open up the app code and tell you a little bit about how to make this stuff work. So we're going to go to this particular directory that's shown up on the top of the screen when you download the TensorFlow GitHub repo, when you clone it, that is. Now, one thing that's interesting about this recently is that it's not actually there anymore. What they've done is they've pulled this off into TensorFlow/examples. And so if you try to go through TensorFlow Lite, it's not there. However, what I noticed is that they actually pulled out all the Bazel stuff from TensorFlow examples. So what you need to do is actually go to an old commit of TensorFlow repo. And once you find an old commit with like the last commit for this one, for instance, then you'll actually see the code there in its spot before it was deleted. So it's important that you go back in the Git commit history and find these files in their original state. And I'll show you why Bazel makes such a big difference later. It's important. So besides doing this, you'll add your SceneForm dependencies to your Gradle build. So how many of y'all use, like our Android developers using Gradle? Oh, wow, okay. So I'd say this is definitely more than in Cambridge, so that's good. Anyway, Gradle is basically your build tool that you use to compile the Android app, and adding a SceneForm dependency is just a little one-line insertion of what SceneForm is, what version you want, et cetera. So it's pretty straightforward to do that. And of course, upgrade your Gradle build to the latest build tools. Now adding the AR permissions to your Android manifest, this is important because Android apps have permissions, of course. You've got permissions for GPS, location, Bluetooth, sending and receiving pictures, files, etc. You're going to want the AR permissions as well for this one. Now, When we take this existing code from the TensorFlow repo, we are going to then also look at the code lab for AR and for scene form. Now they have a particular class in there called AR fragment, and you can basically just kind of duplicate this into the TensorFlow repo with some slight modifications. So as in TensorFlow repo, you're going to find something called the camera activity. Now the camera activity is the thing that actually does the object detection from your application. So as you're running the TensorFlow example, and I'll show you this when you first start off, is it is basically detecting objects on screen, drawing the bounding box, and giving you what it is, or its guess as to what it is, and the probability of it. But now, because it's not doing any of the AR stuff in there, you actually need to implement the AR stuff into the camera activity so that it now knows how to draw the 3D objects onto the bounding box guesses that it's making. So let's continue along. So as you have the standard stuff, this is the code thus far. So without any of the AR stuff, without any of the basal build stuff, you see I'm panning along my collection of retro computers, and the object detection's working, but it's not doing object tracking. You see the colors flashing around everywhere. The colors indicate the indices of the object that is detected on the screen, and with such terrible object tracking, well, it's going to be really difficult to populate your augmented reality objects because you're going to be drawing way more than you need to. So let's talk about the next piece, which is how to build the basal. And this is going to smooth the object detection out and improve the tracking on the recognized entities. So in this case, when you clone the Git repo and you switch, you can do git commit and then type in the long name of the particular commit number that has this old code in there from the TensorFlow repo. You'll find a file called workspace for your basal workspace. You simply need to define the variables for Android SDK and NDK in there so it knows the paths to how to build using the SDK and NDK. Then you cd to TensorFlow, just the root directory of what you checked out. And this is where you run basal build and then the path described above. Now this goes all the way down into the subfolder containing the actual code that you want to build. It gets those instructions from there to build the Android binary that does object tracking. But if you start by building from this directory, it's going to miss a lot of dependencies that come through from the higher level or from the lower level directories closer towards the root. So you really want to make sure that you drill down specifically from towards the root and down into the project you want when you're building your basal build. And this is going to be an important basal, I guess, piece of knowledge to remember if you ever go on and do stuff with basal in the future. And then, of course, some funky Windows business, again, because I like to beat my head on tables constantly and deal with this kind of stuff. So one thing that was interesting is you can't have spaces in your user name. So like if I have my name Stephen Wylie as my user account, on Windows it's going to give error messages because it doesn't know how to get past the word Stephen with the space. It's just going to error out and say it can't find the file. Well, that's great. Thanks for that. So you might have to create another user account with just a single word for the username, and then this will permit your basal build to go forward. Then just pray hard. It is basal after all, and so one thing is that once you get past all the error messages, you might find that it takes a good 5 minutes or so to build. Now, if you've ever tried to build TensorFlow with basal, you'll find it takes more like 20 or 30 minutes. Now, this is on a local machine. If you're doing this on a distributed network, it's probably going to be a whole lot faster because really basal excels at doing distributed builds for huge, huge systems. But running it on your laptop can be also a bit of a head-banging challenge. So what success looks like, you'll see essentially the output of various warnings that are coming through, possibly depending on how your build's going. But ultimately, you see build completed successfully, 200 total actions. You see the time of it was 253 seconds, I think, or 213 seconds to get through this whole build process. So definitely not negligible. Go up and stretch your legs, get a little cup of coffee or something while this is happening. Anyway, once we incorporate this library into the code, now you're seeing that the object tracking is working quite a bit better. You see that the same colored boxes are generally staying on the same monitors, which is a useful thing for drawing the augmented reality. Cool. Ooh. All right, so moving on. Now I will tell you, let's see, that for the augmented reality code, we're going to finally use the output from the bounding boxes that are detected by the object detection model. So, unfortunately, we can't use Bazel anymore. We used Bazel to build the one binary that actually does the object tracking, but now we've got to incorporate that binary back into your Android JNI libs folder. JNI libs is a directory that you use, which then has subfolders that are processor specific, like ARM EABI v7, for instance, or x64, stuff like that. Basically for these system libraries that are compiled down as not Java code, but native code specific to that processor. And you incorporate those into your app, and it automatically kind of incorporates them and lets you use them in your Java code. And so that's what we're doing with the object tracking library, putting it in here. Then, that's kind of what I was describing with set the parameter for the CPU architecture in Gradle as well. Do that. Now, your scene form, what's interesting about scene form is that you may find different versions of scene form as your dependency versus the plugin that you install into Android Studio. Because Android Studio has a plugin for scene form that will automatically help you render the 3D objects into the proper form to be rendered on Android with scene form. So you'll take them basically from an OBJ, render an SFA with your metadata. It finally makes an SFB file, which is what Android scene form actually knows how to render. So that's important if you end up having a mismatch and you end up totally borking Android Studio for some reason. The good news is all this is doable with Gradle instructions. So you don't even need to worry about the manual process of clicking on some plugin to convert your OBJs. Just use a couple lines of Gradle. It solves your problem with building these files. Then finally add your augmented reality code to multi-box tracker. Now multi-box tracker is one of the classes that comes from the scene form, the code lab. And basically, actually, the multi-box is from there. Now, what you need to do though is as you draw the object or the bounding boxes, you're going to be using the corners of these bounding boxes and calculating kind of what you think is the center point of the whole box. From there, you're going to perform a hit test. And this hit test is going to basically tell the augmented reality engine, you know, this is where the floor is relative to the object or relative to the camera. Or perhaps if there's a vertical object, it's going to detect that too and perform the hit test on the side of an object. And so by doing this hit test, it basically establishes a point in space where you can render the 3D object. And let's see what that looks like. So now you can see, opening up the app, and I'm kind of dragging my phone along the floor so it can build that representation of what the world looks like. It's tracking the floor now with the dots, as you can see. Now it's picked up on the chairs, and it's trying to perform hit tests on the corners, or towards the center of these boxes. And once it finally gets a successful hit test along the floor, then you'll see that it draws a little Android figurine in the center of the chair, and pops up a couple other ones. You see it did a little too many right there. And we'll explain a little bit about that later on. But you can see it's kind of just like going along and humming along. So now it's time to profit, or not, because there's still a lot of work that needs to be done to clean this up. And now we're going to the pitfalls section of AI plus AR, things to keep in mind. Look at this guy over here, right? He's going to burn down your phone because you're running machine learning plus AR at the same time. So one technique you can do to avoid killing your battery and turning your phone into a piece of thermite, basically, is to toggle exactly when you're running your AI versus your AR. For instance, if you're up here moving around a whole bunch, then chances are the quality of the image on your camera is not that good, and so you might not get such a useful object detection piece from it. Instead, utilize the notion of the augmented reality with its sensors to keep track of how the device is moving in space, and only use the AI when the device is relatively stationary. The other thing is the depth and the size of object. Now, basically, to summarize what I'm saying up here is you've got models from, not necessarily machine learning models, but your 3D models from 3D Studio Max or Blender or whatever you're using. Now, these things all have a certain size in the space of their world. Now, your size might be relative to the scale of a dollhouse, a real tiny object, or it might be the size of a big old bus or something like that. But you've got to be cognizant as to the size of your 3D model versus the size of the environment that the user is going to be interacting with or else they might end up with a really uncomfortable user experience where let's say that they're trying to, glom off of this coffee cup here, and then all of a sudden the model renders so big they got to really rack back so far they're about falling over. So you don't want that experience whatsoever. So one thing you can do is then you can correlate the bounding box with the hit detection. Now what I mean by this is that basically the bounding box in space is going to be of a certain size relative to the camera. And you know, kind of with geometry, exactly how far away something is based on the angle that it is from the screen. And so through some mathematics like this, you can essentially find the angle and then scale the object relative to how far away the estimation is based on how low or how high up your bounding box is. And this could potentially help you solve the scaling issues. Then let's talk about sensor drift because it's hardware. It's basically borderline IoT a little bit. So if the object falls out of the viewport, you might be interested in why there's drift happening. And drift is when, let's say, like the Android jumps from here over the coffee cup to now a few feet over. And this is a big problem. Like if I'm sitting in my bathroom playing with this, you'll find that the Androids definitely drift around a whole bunch because there's not many reference points in there whatsoever to glom onto. Because the AR is relying on point clouds generated by hardware sensors. Hardware sensors drift, unfortunately, and the objects anchored by the world space are likely to wander off. So make sure that your scene that you're in, like the user scene, has good contrast. Enough corners to see every frame. There's corners of interest are the ones with the high contrast, like this black and white corner up here that you see all along the tops of the rooms. That's pretty good stuff. The second thing you want to do is attach objects to anchors. Now, anchors are really cool because it basically helps you mitigate in space where these objects are, and you can say an anchor is attached here, and then you can make an object relative to these anchors in space, and also you can see if an object is already associated with an anchor, and if it is, then just don't draw another one there. So it also helps you conserve some memory ahead of time as well. And then, of course, scan enough of the scene ahead of time, like you saw with that little phone icon earlier, where it was telling you, kind of insinuating that you need to scan the floor. Then, let's talk about tracking multiple objects, like you saw with my big bunch of computer monitors. You see that object detections could be straight up wrong, they could be missed, or they could just flip-flop IDs, as you saw with the colored boxes that were changing earlier on. So one way that you could reconcile this is to discover the correlations between the objects moving on camera. You could use possibly pairwise dependencies or some cutting-edge research with non-uniform hypergraphs. Could be a bunch of different ways to solve this. However, just build a library in Bazel that's going to solve a lot of problems. Otherwise, you're going to have to code it yourself. So to mitigate this, definitely take the time to set up your NDK properly, get that Bazel build working, and you're going to want to also minimize the anchors as you instantiate objects, because anchors do take up a lot of memory, and so you're going to want to basically just have one of them, and then by tracking one anchor, it's going to be a lot simpler to track these things, and when you're trying to track multiple anchors, it could all get messed up. So that is it from me, and here is my Twitter handle, my blog. Apologies to those of you that were expecting the talk on voice customization, but you can definitely catch it on my blog when it gets posted. And then the slide share, these slides are available. You can check out the GitHub repo as well, so you can find out how to build this thing for yourself. And it looks like we already got a question.